Another method of factoring is by using sum of cubes or difference of cubes. So sum means add, difference means subtract. So if you have two terms that are cubed and are added, you can use the formula a cubed plus b cubed equals a plus b times a squared minus a times b plus b squared. So in order to do this, you need to determine what a and b are by cube rooting them. Difference of cubes, you're going to take the cube root of each, and then you'll have a minus b times a squared plus ab plus b squared. So these are formulas that you don't have to know, but you need to know how to use. So the first thing that when you're factoring these is you need to identify what a and b are. So you're going to do the cube root of the first term, and that's going to be your a. So the cube root of x cubed is x. And your b is going to be the cube root of the second term. So the cube root of 1 is 1, because 1 times 1 times 1 is 1. So now this is going to be the sum of cubes. So I'm going to use this formula because I have a cubed plus b cubed, x cubed plus 1. And now I'm just going to plug it into this formula. So it's going to be a plus b, so x plus 1, parentheses, a squared, which is x squared, minus a times b, which will be x times 1, and then plus b squared, so plus 1. And that's it. So the second one, to find a, this is going to be a difference of cubes. So I'm still going to take the cube root of the first term and let that be a. So that's going to be 3x, because the cube root of 27 is 3, and the cube root of x cubed is x. Then I take the cube root of 8, which is 2. So this formula already accounts for the subtraction. See, there's a subtraction right here. So I'm just going to plug it into difference of cubes. So it's going to be a minus b, so it's going to be 3x minus 2, parentheses, a squared. So a squared is actually going to be 3x squared, and that's probably the biggest mistake that people make with this. So it's not just going to be 3x squared, it's going to be the quantity 3x squared. So that means you need to square the 3 and the x. So this is actually going to be 9x squared. So ax squared plus ab, so plus 6x, plus b squared, which is 4. Okay, the last one, I'm going to take the cube root of 64, which is 4, and the cube root of y cubed is y. So again, you're ignoring the negative, and I'm going to plug it into this formula up here. So this is going to be a minus b, so 4 minus y, times the quantity a squared, so that's 16, plus ab, so plus 4y, and then plus b squared, so plus y squared. So if you want to, you can just do the distributive property, multiply 4 by all three terms, and multiply y by all three terms, or negative y by all three terms, and see if you get 64 minus y cubed. That's how you can check your answer. Okay, now we're going to step it up a notch by factoring and then solving the remaining quadratics. So these are different than up above because we have an equal sign. So this is going to be an equation. So this is difference of squares. So the a is going to be the cube root of x squared, which is x, and b is going to be the cube root of 1, which is 1. So I'm going to use the difference of squares formula. So this is going to be x minus 1 times x squared plus ab, so x squared plus x plus 1 equals 0. Now, this is factored, so my solution is I'm going to use the zero product property and set each one of these equal to 0. So I have x minus 1 equals 0, and then x squared plus x plus 1 equals 0. So my solution is going to be x equals 1, so I write that right here. But then I also have a quadratic right here, which has a potential for 2 solutions. So I cannot solve this by factoring. It doesn't factor out, so I'm going to use the quadratic formula. So it's going to be x equals negative b, so negative 1, because b is 1, plus or minus the square root of b squared, which is 1, minus 4, times a, which is 1, times c, all over 2a. So underneath the square root is going to be 1 minus 4. So that's going to be x equals negative 1 plus or minus the square root of negative 3 over 2. So we've learned back in chapter 5 that when we have square roots of negative numbers, they are imaginary solutions. And we can do that. So the square root of negative 1 or negative 3 is going to be, so negative 1 plus or minus root 3i, the I is on the outside, over 2. So these 3 are my solutions. It's degree 3, so by the fundamental theorem of algebra, there's going to be 3 complex solutions. So this is one solution, and these are 2 solutions because we have a plus or minus. Okay, let's do this similar for the next one. Next one we have sum of cubes. So I have to find my a and my b. So this is going to be a is 2x because the cube root of 8x cubed is 2x. And b is going to be 5. So I'm going to plug this into my sum of cubes formula. So it's a plus b, and then it's a squared. So it's going to be 2x squared, which is 2x times 2x. So that's going to be 4x squared. Minus ab, so that's 10x, plus b squared, which is 25. Equals 0, because it's an equation. So now I'm going to use the zero product property and do 2x plus 5 equals 0. So this will be x equals negative 5 halves. So one solution is negative 5 halves. So for this part of the solution, I need to use the quadratic formula again, because it does not factor. Okay, so really by general rule, when you factor sum of difference of cubes, the quadratic will never factor. Okay, so you're going to have to use the quadratic formula. So it's going to be negative b, so it's 10 plus or minus the square root of b squared, which is 100, minus 4 times a times 25, all over 2a, so all over 8. So now I'm going to do underneath the square root, this is going to be 100 minus 400. So this is going to be 10 plus or minus the square root of negative 300 over 8. So I can reduce this, the square root of negative 300 is going to be 10 root 3i, so I'll have 10 plus or minus 10 root 3i over 8. Now the reason it's 10 root 3 is because the square root of 300 is the square root of 3 times 100. So the square root of 100 is 10. And then I have an I because this is an imaginary number. So now I can reduce, if I can divide all 3 of these terms by the same number, I'm going to have divide 10 by 2, 10 by 2, and 8 by 2. I will have 5 plus or minus 5i root 3 all over 4. So those are 3 solutions, and it's degree 3. Because there's one solution right here, and there's 2 solutions right here in the terms of being a positive and negative. Okay, and the last one, your A is going to be 3x, because the cube root of 27 is 3, and the cube root of x cubed is x. And then your B, the cube root of 64 is 4. So factored, it's going to be a plus b, so 3x plus 4, times a squared, so 3x squared is going to be 9x squared, minus 12x, because it's minus AB, plus 16. So, and this is an equation, so it's equals 0. So I can use the zero product property and set the first term equal to 0. So that's going to be 3x plus 4 equals 0. 3x equals negative 4. X equals negative 4/3. So it's negative 4/3. And I'm going to use the zero product property and use the quadratic formula to solve this quadratic right here. So it's going to be negative b, which is 12, plus or minus the square root of b squared, which is 144, minus 4 times 9 times 16, all over 18, 2a. So if I do 144 minus 4 times 9 times 16, I get 12 plus or minus the square root of negative 432 over 18. So I know it's going to have an imaginary number with it. So I know it's going to be 12 plus or minus the square root of 432i, i's on the outside, over 18. So now I have to break down the square root of 432. So actually the highest perfect square that goes into 432 is 144. So this breaks down into 12 plus or minus, this is 144 times 3 is going to give you 432. So the square root of 144 is 12. So it's 12 root 3i over 18. And your last step is to divide each of these, or find the highest number that 12, 12, and 18 can be divided by. In that case, it's 6. So your answer is going to be 12 divided by 6 is 2, plus or minus 12 divided by 6 is 2 root 3i over 3.